The root test is a test for both convergence and divergence of an infinite series. So your series converges if the limit of your nth term with absolute value nth root is less than 1, and it diverges if the nth root of the absolute value is greater than 1. Now, it's inconclusive if it equals 1, so it's a lot like the ratio test. Converges less than 1, diverges greater than 1, inconclusive equals to 1. For you to be able to do the root test, you have to be able to take the nth root. So what you're looking for are things raised to the nth power, and everything has to be raised to the nth power for this to actually work. So it may be obvious, like example B. So you would say, oh, okay, I'm going to do the root test, and I'm going to say I'm going to take the limit as n approaches infinity of, I'm going to do the absolute value, and I really don't need the absolute value because if you plug in 1 or any number, these are positive because we're going from 1 to infinity, but say we're doing the absolute value, 3n plus 4 over 2n to the nth absolute value with the nth root. And I want to know what that is. The nth root of something to the n cancels out. So I'm doing the limit as n approaches infinity of 3n plus 4 over 2n. And I want to know what that limit equals. Well, this is, if I evaluated infinity, it's 3 times infinity plus 4 is definitely infinity over 2 times infinity, infinity. So you can use L'Hopital's and take the derivatives. The derivative of the numerator is 3 with respect to n. The derivative of the denominator is 2, so it's 3 halves. Or do dominant terms because the limit is as n approaches infinity. Either way you do it, this limit is 3 halves. And what's important about the 3 halves is that it's greater than 1. So this series diverges by the root test. And these really are fairly obvious because you have the nth power. On this one you can see that this is e to the 2n over n to the n. If I actually simplified this a little bit, or I guess unsimplified, this is really like an e squared over n to the nth because you'll multiply your powers n. This is a 1 right here. So when I actually do the nth root of the absolute value of this, and again my n is starting at 1 and going to infinity, so I don't really need the absolute value. What I'm really checking is the limit as n approaches infinity of just this inside piece here, e squared over n. Well, e squared is a number, and e is a little less than 3, so this number is definitely less than 9 divided by infinity. So we're dividing by something really, really large, and this is going to be very, very small. In fact, this is going to be 0. And what's important about this being 0 is that 0 is definitely less than 1. So for our root test, if our limit is less than 1, we know that this series converges by the root test. And that is it for the root test.